multi-part series re- with regarding this software design pattern. So in the last two episodes, we looked at the design pattern, and we looked at the definition of design pattern, and we looked at the value of design pattern with some real-time examples. Now let us continue with this presentation talking about the design principles. So design principles is another important topic that we need to learn before we jump into the individual design pattern. Okay, first of all, what is design principle? Why are we talking about design principles in a topic that is targeted towards the software design pattern? So, yep, this is very important to understand design principle. Design principle, as the name suggests, it is a principle or a set of guidelines in designing an application. This is one last thing that we need to know before we discuss about the design pattern. Okay, in other words, design principle can be termed as a set of best practices that a developer should follow in designing an application software. Okay, so why or how it is related to design pattern? See, design pattern tries to solve the common problem, and design pattern tries to follow the design principle, because design principle is a best practice. Our solution should be following the best practice. So design pattern will try to adhere and follow the design principles. So understanding the design principles will help us to appreciate and understand how a particular design pattern is trying to follow a specific design principle. So because once we have the understanding of each of these design principle, when we look at the design pattern, we will be able to tell, oh, okay, fine, this design pattern is trying to follow a single responsibility principle. Okay, or it is trying to insist an interface segregation principle or whatsoever. So understanding the design principle will um, uh, help us to better understand the design pattern. Okay, so these are the couple of points, like developing software design should follow the design principle. Design principles are intended to make software design more understandable, flexible, and maintainable. And design principle significance with design pattern is that understanding design principles will help to appreciate the technical details of software design pattern. Design pattern adhere follow the design principles. Okay, so we talked so far in a generic way about the design principle. So let us look at the detail. Like, can we say like how many design principles are there, or there a count for that, or what are all those design pattern? Is there any name for each design pattern? Yes. To answer all these questions, yes. We have totally 5 design principles, which is shortly referred as a solid principle. So SOLID. Each letter is an acronym for a design principle, abbreviated, like S for single responsibility, O for open closed, L for risk of substitution, I for interface segregation, and D for dependency inversion. Let us look at what each of them talks about. But before that, just we want to understand some basic fact about an application. So because that is very mandatory to appreciate the solid principle. So if you look at an application, like a completed application or a software, it consists of lot of parts in it. It is similar like an any product, any completed product. If you look at an electronic product like a television or a computer or whatsoever, it contains lot of parts within it. Similar to that, an application software consists lot of parts composed in it. So these parts are called as components, object, module, library, DLL. They have a lot of different terminologies, technical terms used to refer these parts. But just for consistency, let us refer to them as components. Sorry, as an objects or class, because in object-oriented programming, it is referred as an objects or classes. Let us follow that same term in this session, in this presentation, to refer to a part of an application. So, okay, why we are talking about the application composition and part? Because solid principle insists or gives a guideline of how to design a part, which is a class or which is an object. So all these principles, 5 solid principles, are tightly related to the design guidelines on designing a part of an application software, which is a class. Okay, so this diagram just in a high level, it depicts about the application composition, how, and if you look at an application composition, how it looks like. It will have a lot of components which is interacting between them through an various mode of interaction, like an inheritance or an dependencies and those sort. So this is just an high level a diagram that depicts the relationship. Okay, now let us look at the each design pattern. So S is a single responsibility principle, O is for an open close principle, L stands for Liskov substitution principle, I stands for interface segregation principle, and D is for dependency inversion principle. Okay, just I want to highlight this presentation. This presentation is for focused on design pattern. Talking in detail about solid principle will will require and separate a video in detail. Just in this presentation, I'm going to cover it at a very high level about the solid design principles. What are all those 5 design principles? What it means. So it will be sufficient to carry on with this conversation or presentation to understand the design pattern better. So I'll be providing as much as information, but it will not be too. I will not be talking in depth about these 5 principles. Okay, let us look at these 5 solid principles. What are they? So see, S stands for single responsibility principle. So this principle talks about how to develop a component, as I already mentioned. So one of the principle is to ensure a particular class or component just takes care of one responsibility, a single responsibility. Means like, in other words, we shouldn't overload a component with a lot of functionality in it. Okay, so means like, just to correlate to a real life example, think of the John scenario. When John initially developed that product application, he doesn't follow this principle. He tried to put everything in one component, and when later clients came to him with the varying requirement, he need to he end up with refactoring the code to make it modular. So this is all about that. We should not put all the functionalities in one single component or a class and make it too much tightly coupled. We need to make it highly modular by keeping the responsibility of a class to a very minimal level. Just we need to ensure it does just one, it takes care of one single responsibility. Okay, to talk about in a more practical example, let us think like we are developing a component which takes care of validating the data and persisting the data to a database, like an employee component which validates the employee data and persists that employee data into the database. So here, if we look at the features, we see 2 major features. Like, one is validating the data, which takes care of validating the name or age or city or whatever sort of validation. And the second part is persisting the data to the persistent storage, like a database. So this indicates that we want to make it as a 2 different components. So we shouldn't put these both features in one single component, and that is against the rule, single responsibility principle rule. It violates the single responsibility principle. We want to make sure that each feature should reside in a separate component, like validation should reside in a separate component and persistent logic should reside in a separate component. Okay, why we need to do like this? What is the benefit? Because we can maintain the individual feature separately in a separate component. So tomorrow, if you want to change the persistence logic, today we are persisting to a database, tomorrow we want to persist to a file or some other mechanism, like an other database or an a service bus or whatsoever. So if you want to change that one, we shouldn't go and change one single component which is responsible for multiple things. So if we have the persistent logic separately, we can change that in the isolation without touching the validation component. So similarly, if tomorrow if we have some validation rule, so we don't need to touch the persistent logic. So that is one key thing that single responsibility principle helps, isolating the logic in a separate component. So that is what all about single responsibility principle. Okay. Second thing is open close principle. So a component should be closed for modification, but it should be open for adding new feature. Okay. So it means like if we want to add a new functionality to an existing component, we shouldn't do that by modifying an existing component. We should be able to do that by adding a new component into the system where that new component takes care of a new functionality. Okay, this may look slightly confusing, and especially the term when it talks about closed for modification. So you don't think that closed for modification is something like it is explained in a bit different sense. So because when people see closed for modification, they will ask a basic question: hey, how a component can be closed for a modification? It should be open, right? If I want to if I find any defect, I need to open that particular component to fix the changes, like for any modification. So how can it this can be closed for modification? So no, this rule doesn't talks at that level. This rule talks about in a very high level. If you want to extend the functionality, existing functionality, we shouldn't open an existing implementation and change it. To talk about in a very more realistic example, assume we have an export to CSV or export to Excel component built. Tomorrow we decided that we want to add an export to PDF feature. So to implement this feature, it is not expected that we need to go and modify or change an existing exporting component which exports the data into the Excel. So we don't want to change that to implement this feature. We should be able to add this new feature as a new class. So it can be a new class we can use as various technical strategy to implement this one, maybe like using a decorator pattern or using a strategy pattern or whatsoever to implement this new feature. So open close principle is all about that. Should be closed for modification, but it should be open for adding a new feature. Let's call substitution principle. Client should treat all the implementation of abstraction equally. Should be able to switch to a different implementation without breaking the consumer. So this is very self-explanatory. If for, we know that mostly when we develop an application, we go by developing based on contracts. We will have the interface definition, or we will have the abstract class definitions, and we will develop a new components or class which follows this abstraction or implements the abstraction. So this rule states a client should treat all the implementation of abstraction equally. For to talk about in a real example, like if we write an export functionality which is for Excel or PDF, so the client should treat all these implementation as of these abstraction equally. So beneath a button somewhere in the client, if export is clicked, exporting to Excel or exporting to PDF should be handled by the respective components. The source substitution should be able to replace or substitute the implementation to a new component. So that is all about Liskov substitution principle. Okay, and the other one is interface segregation principle. This also sounds similar to single responsibility principle. We need to ensure the interfaces are logically grouped, segregated logically. We don't want to put a lot of interfaces in one single component, which makes it too tightly coupled. So we need to ensure these interfaces are logically segregated. Okay, not too many responsibility in one single interface, which sounds similar to the single responsibility principle. And the last one is in the list is dependency inversion principle. So we know in any application components, the components or will be interrelated, or there will be dependency between these components. So when we have dependency between components, we want to make it as much as possible in a loosely coupled way. We don't want to introduce a tightly coupled um, dependency within the application system. So example, if a component is depends on another component, we shouldn't instantiate that component within the container. If we do so, then we are introducing the tight dependency. So it will introduce a tight dependency. So we want to avoid that basically. What we want to do is we want to move the dependency for an object to create a dependency to an external to the component. So this can be achieved by various technical options available, like using a DI container, dependency injection container, or using a factory pattern, or many approaches. So we can achieve that by this approach, but ultimately we want to make sure the dependencies are loosely coupled. So we want to ensure the object, the creating object for a dependency should be outside the code. So these are all the 5 principles. Another thing is, the most frequently used principle in an application design is dependency inversion principle, single responsibility principle, and open close principle. In fact, everything is important, but most practically we would see all these 3 patterns frequently. Okay. Thanks for watching this presentation. We will see the continuation in the other upcoming part of the presentation. This is, as I mentioned, multi-part series or design pattern. You are watching the third part of this presentation. Let us continue rest of the topics in the fourth part of this presentation. Thank you. Have a nice day. Bye.